So this is a typical equilibrium Le Chatelier type question, okay? And we know it's going to do with Le Chatelier's principle because it's an equilibrium. And we know it's an equilibrium because in the middle of the chemical reaction there's a double-headed arrow. So the double-headed arrow means the reaction can go forwards, it's forward direction, or backwards. We also know, because if we look at the question, the reaction is exothermic because it's minus 129 kilojoules per mole. So because it's minus, that means the reaction goes in that direction, it's exothermic. But the reaction goes from right to left, it's endothermic. And when you use that information to explain what happens when you change the temperature. So I like to think of it this way: if it's exothermic in this direction, in that direction it gets hot. But in the other direction, starting with methanol, the alcohol, and going back to H2 and CO, it gets cold. So the question says, describe and explain, so we want two different parts of the answer, how the composition of the equilibrium mixture is affected by increasing the temperature and then by increasing the pressure in the reaction. So let's look at the reaction. What happens when you increase the temperature? The system will want to decrease the temperature. So what we say is, by Le Chatelier's principle, by LCP, system will decrease the temperature. Because remember, the system wants to do the opposite of what you do. If you increase the temperature, it will want to decrease the temperature. The system will decrease the temperature, so it wants to get cold. So the way it gets cold is the reaction goes in this direction. So you would have more carbon monoxide and hydrogen. And the why, is because the forward reaction, the reaction in this direction, going from carbon monoxide and hydrogen to methanol, is exothermic. So forward reaction is exothermic. Second part, increasing the pressure. So pressure is to do with the number of molecules there are in something and the number of molecules that are bumping against the size of your container. So if you increase the pressure of the reaction, what the reaction wants to do? The reaction wants to decrease the pressure. So by Le Chatelier's principle, reaction will decrease the pressure, and the way it will do that, it will change the position of equilibrium, it will change the amount of carbon monoxide and hydrogen compared to the amount of methanol. So it will go to the reaction will move to side with the fewest number of molecules, and the side with the fewest number of molecules is the side with the methanol one. Why? Because there's only one methanol molecule, but on this side, on the left-hand side, there is one carbon monoxide, two hydrogens, so we have three molecules on this side and one on that side. So the reaction will move to the side with the fewest molecules, therefore you'll get more methanol. Part 2 says describe and explain. So we want a describe and explain answer. The effect of increasing the pressure on the rate of reaction. So if we explain first, what you'll find is we'll go over here, explain, there will be more particles. Therefore there will be more collisions. And what effect will that have? The described part, so that means the rate of reaction will increase. Rate of reaction will increase. As with all these questions, if it says describe and explain, you need to have two parts of your answer. An explanation as to why it happens and a description as to what happens. Final part says suggest and explain the effect of a catalyst on the equilibrium position. So a catalyst increases the forward rate, but it also increases the backward rate at the same amount. So there is no effect on equilibrium position, EQM position. That's the suggest. We now need to explain. That's because the forward and backward reactions are catalysed at the same rate. forward and backward reactions are catalysed at the same rate. Catalysed and affected the same.